So in this lecture, we will study the relationship between the structures and the pointers. Okay. So like other pointer variables, you can create the structure pointers by placing the asterisk in front of the structure variable's name. So here is an example. This is the struct address is the tag of the structure, and address pointer, this is the name of the variable which we are creating, and asterisk means this is not a normal variable, this is a pointer variable, pointer to a structure. So it will store the address of a structure. Okay. And here we will discuss how to pass the structures by reference. In the previous lecture, we saw how to pass an entire structure as a value, but there is a problem in that. Uh, there is an overhead which is needed to push the entire structure onto the stack when the function is called. Okay, so when you are passing the entire structure has to be pushed onto the stack. Okay, so entire structure has to be saved. Okay, so that when you return back from the function call, you can access the same state of the structure. Okay, and also this is very it makes the function call slow, and it is also very heavy when you pass by reference, because you have to copy the structures. Okay, you have to make two copies of the same structure, one in the main program or the calling program, and another in the called program. Okay, for simple structures with few members, this overhead is not too great. But if the structure contains many members, or if some of the members are arrays, then of course the performance will degrade. Okay. So what is the solution to this? The solution is to pass the structures by reference. Okay. So instead of passing an entire structure, we pass the address of the structure. So when a pointer to a structure is passed to a function, only the address of the structure is pushed onto the stack, not the entire structure. Okay, so we do not need to copy the entire structure, we just copy the address, we pass the address. So this makes the function calls fast. So here is an example. We have a structure balance. Structure balance contains two variables, float balance and char string name. So this is a string, this is an array which is of length 80, so it contains 80 bytes, plus this balance, this is a float, it contains 4 bytes, so total this structure will occupy 84 bytes. And here we are creating a variable of this structure whose name is person. So with this, memory will be allocated to this structure equal to 84 bytes. Okay, and we can access this memory using the name, not balance, using the name person. Okay, and this is the float member, suppose, and this is the char member, char array. Okay, and what are we doing here? We are creating a structure pointer. Struct val, it signifies to which structure we are referring, means what is the data type of this variable p, and asterisk means this is a pointer. Okay, so we are creating a pointer to a structure somewhere in the memory. So this is intended to create contain the address of a structure, and then we are assigning p equal to address of person. So this is person in the memory, and it will have some base address. Suppose it is starting at 1000, then 1002, 3, 4. These addresses 1001, 2, 3. These addresses are occupied by this float, and the char is starting at 1004 up to 1083. So this is occupying total 84 bytes. But when we talk about the address, we say only the base address, where that block of memory is starting. So here we are passing that base address. So P contains address of person means it does not contain the address of all the bytes of person. It only contains the address of first byte of person. So it will contain the base address, that is 1000. So this pointer is pointing to this structure. Okay. And how can we access the members of a structure through pointer? Using the arrow operator. To access the members of a structure using a pointer, you can use the arrow operator. For example, in the previous example, the structure balance contains members, float balance, and a character string char s80. Okay, so we create a pointer to that structure, and name of the pointer is p. But if you want to access these balance and s using this pointer variable, you do not need to use the dot operator. Instead, you have to use the arrow operator. Arrow operator balance. In this way, you can access this balance variable. Okay, so this arrow operator is called member dereferencing operator. So this is also called member dereferencing operator. So in this way, we can access the values or the members of a structure through a pointer using the arrow operator.